Hello everyone, this is Mr. Srinivas. I am working as assistant professor in the Department of Electrical and Electronics Engineering at Marri Laxman Reddy Institute of Technology and Management. Today, I will be giving a brief introduction regarding the subject basic electrical engineering. So in this, I will be discussing about the first module, nothing but the DC circuits, in which I will be discussing about the basic concepts of the circuits, that is the classification of circuits and the basic definitions related to these DC circuits. So in this, the contents are active elements, independent and dependent sources, passive elements, that is resistance, inductance and capacitance, energy storage elements, that is inductance and capacitance. And also in addition to this, I will be discussing about the Kirchhoff's laws, source transformation methods, star delta transformation, and nodal voltage method and mesh analysis. So regarding the DC circuits, as a part of introduction, any electrical circuit may consist of one or more sources of energy and number of electrical parameters connected in different ways. The different electrical parameters are nothing but the resistors, inductors and capacitors. The combination of such elements along with various sources forms a network, and the term circuit and network are synonymously used in the electrical literature. Simply, a simple electrical circuit consists of three basic elements. One is the energy source, nothing but a battery, and the second one is a load or sink, that is, it may be either a lamp or motor, and connecting wires. The purpose of the circuit is to transfer the electrical energy from the source, that is the battery, to the load by means of these connecting wires. So, more specifically, I can say interconnection of two or more simple circuits is called an electrical network. So coming to the first definition, the term voltage. So according to the structure of an atom, we know that there are two types of charges. So one is the positive charge and the other is the negative charge. A force of attraction always exists between these positive and negative charges. A certain amount of energy is required to overcome the force and move the charges through a specific distance. All opposite charges possess a certain amount of potential energy because of the separation between them. The difference in potential energy of the charges is called as the potential difference. The potential difference in electrical terminology is called as voltage, and it is denoted by a letter V. Usually, it is expressed in terms of energy per unit charge. So V is equal to W by Q. So in terms of smaller quantities, it can be represented by V is equal to dW by dQ. And coming to its unit, so the unit of energy is joule and that of charge is coulomb. So therefore the unit of voltage is joule per coulomb, or simply it is represented by the term volt. From this, 1 volt can be defined as the difference between 2 points when 1 joule of energy is used to pass 1 coulomb of charge from one point to another point. Next definition, current. So as usual in the atomic structure, if I consider any atom, there are free electrons available in all semiconductive and conductive materials. These free electrons move at random in all directions within the structure in the absence of external pressure, that is voltage. If certain amount of voltage is applied across the material, all the free electrons move in one direction depending on the polarity of the applied voltage. This movement of electrons from one end of the material to other end constitute an electric current denoted by the letter I. The conventional direction of current flow is opposite to the flow of negative charges, that is the electrons. Therefore, we can define the current as the rate of flow of electrons in a conductive or semiconductive material. Usually, it is measured by the number of electrons that flow past in a unit time at a point. It is expressed mathematically as I equal to Q by T. Here Q stands for the charge and T stands for the time. And coming to the unit, it is represented in terms of coulombs per second or ampere. And next, the term power. It is defined as the rate of doing work it is represented by the letter P. So we can define or represent P is equal to work done per time, and the SI unit of power is Newton meter per second or joule per second. And coming to the definition of electrical power, it is defined as the rate at which work is done in an electrical circuit. So therefore, power in an electrical circuit can be defined as the work done in an electrical circuit by time. So the work done is represented as product of voltage into current into time, and therefore the ratio is now equal to V into I. And the unit of electrical power is kilowatt or megawatt. Power is the rate of change of energy and is denoted by either P or small p. If a certain amount of energy is used over a certain length of time, then P is equal to energy by time. So P is equal to W by T. So the term W by T can be also represented as dW by dQ into dQ by dt. So I am simply multiplying and dividing the ratio dW by dt by dQ. So from the basic definition of voltage, dW by dQ nothing but stands for voltage, and the second term dQ by dt stands for the term current. So therefore from this we can define the unit of power as volt ampere or simply watt. So from this we can define 1 watt is the amount of power generated when 1 joule of energy is consumed in 1 second. Next, coming to energy. So energy is the capacity to do work, or it can also be defined as the stored work. So energy may exist in many forms such as mechanical, chemical, electrical, and so on. So coming to electrical energy, it is defined as the total amount of work done in a electrical circuit. It is measured by the product of power and time. So therefore we can write electrical power is equal to product of power and time. So from the definition, power can also be represented as voltage into current and into time. So therefore the unit of electrical energy is watt second or watt hour. For higher quantities it is represented in terms of kilowatt hour. Next, so coming to the classification of circuit elements. So basically the elements are classified as linear and non-linear, active and passive, unilateral and bilateral, and also time variant and time invariant. So the very first one, linear and non-linear elements. So element is said to be linear if its voltage current characteristics at all the times is a straight line from origin. For example, the current passing through a resistor is proportional to the voltage across it. So which is defined by the Ohm's law, nothing but V is proportional to I or V equal to I into R. Therefore we can say that resistor is a linear element. A linear element is also defined as one which satisfies the principle of superposition. That is, it must satisfy the principle of homogeneity and additivity. An element which does not satisfy the above principle is called as a non-linear element. So the examples for linear elements are resistor, inductor, and capacitor. The characteristics of a linear element can be as shown below. In both the cases, if I consider the relation between voltage and current, the graph is a straight line start from the origin. And also in the second case, if the polarity is reversed, the characteristic is passing through the origin. So these two cases represent the linear element characteristics. So coming to the non-linear element, the element which does not satisfy the linearity concept, nothing but if the VI characteristics does not follow the one equation and does not follow Ohm's law, then it is called as non-linear element. For example, semiconductor devices like diode, BJT, JFET, SCR can be considered as non-linear elements. The characteristics of the non-linear element is as shown below, so which does not start from the origin. So this is example for non-linear element. And similarly in this case, these characteristics can be considered to be that of a non-linear element. Next, the second part of the classification is active element and passive element. So based on the power delivering or absorbing capacity or capability, the elements can be classified as active elements or passive elements. So coming to the first one, active element. Active element is such an element which is able to deliver energy to the circuit. That is, in an electrical circuit, if an element can supply electric power to the circuit or power gain in the circuit, it is known as active element. Some common examples of active circuit elements are the energy sources, nothing but the batteries, generators or alternators, semiconductor devices such as transistors, photodiodes, and etc. The active elements are the circuit components which are entirely responsible for the flow of electric current in the circuit. Next. So these are the examples for an active elements: generator, battery, and transistor. Next, coming to the passive component, the circuit element which can only absorb electrical energy and dissipates it in the form of heat or stores in either magnetic field or electric field is known as passive component, or simply a passive component. So therefore, a passive component cannot provide electric power or power amplification in any circuit. Some common examples of passive circuit components are resistor, inductor, and capacitor. In this, resistor dissipates energy in the form of heat, whereas the elements inductor and capacitor stores energy in the form of magnetic field and electric field respectively. And coming to the next classification, unilateral and bilateral elements. As the name itself indicates, uni means one direction, bi means either direction. So coming to unilateral, an element is said to be unilateral if the flow of current through the element is only in one direction. A constant current and voltage source, diode, FET, BJT, etc. are the examples for unilateral elements. So coming to bilateral, if an element has the capability or ability to pass the current in either direction, then it is called as bilateral element. The examples for bilateral elements are resistance, inductance, and capacitance. Next classification is time variant and time invariant elements. So an element is said to be time variant if its VI characteristics changes with time. Otherwise, it is known as time invariant. And one more classification, that is lumped and distributed elements. Lumped elements are those elements which are very small in size and in which simultaneous actions takes place for any given cause at the same instant of time. The typical lumped elements are resistance, inductance, capacitance, and transformers. Generally, the elements are considered as lumped when their size is very small compared to the wavelength of the applied signal. Distributed elements, on the other hand, are those which are not electrically separable for analytical purpose. For example, a transmission line which has distributed resistance, inductance, and capacitance along its length may extend for hundreds of miles. So this stands an example for the distributed element. So these basic definitions I have taken from the reference books, that is Electric Circuits by Sudhakar and Shyam Mohan and Network Analysis by U.A. Bakshi. So let me meet in the next session. Thank you.